Hello everyone, my name is Erika and this is my co-speaker Petteri. And
Hi.
Okay, let's start with the next session. Please go ahead.
yes,
Thank you.
So hello everyone, I'm glad to see so many of you here. My name is Erika, and this is my co-speaker Petteri. And today we're talking about getting ready for the upcoming EU cybersecurity regulation in software supply chains. So, as mentioned, my name is Erika and I work as a software engineer at Kraki.
And my name is Petteri, and I'm one of the 4 co-founders of Kraki, and my key focus areas are in security and innovation. So let's go. First, quick introduction to Kraki. We are both from Kraki, and our mission is to develop solutions to secure software supply chain. More specifically, we are developing technology that creates provably complete SBOMs from your builds, ensuring that no dependencies are missed. We are building fully European CI/CD service that easily integrates into existing CI/CD tooling. And with only 5-minute setup, you can get increased visibility into your software supply chain. And we can also help you to reach compliance. We also have a booth here at KCD, so if you are interested around these topics, please come and visit us. So, let's go quickly through the presentation outline. Our focus in this talk is in the open source tools and concepts. We begin the journey by diving into software supply chain security and recent software supply chain security attacks. Then we take a closer look in the regulatory pressure and coming regulation, as well as the Cyber Resilience Act. And after that, we will dive into SBOMs in more detail, and we also have a live demo. Yeah.
So, of course, if we want to talk about software supply chain attacks and how they kind of look like, we first need to understand what a software supply chain is. Many of you were probably at the keynote earlier this morning, and there I've used the exact same definition because it's very nice. So it's a list of components, libraries, tools, and processes used to develop, build, and publish software artifacts. So like quite intuitively, this means a bunch of open source dependencies that you might use. You do npm install and so on, or even like compilers that you use to compile code. But it also includes, importantly, internal libraries and tools. Additionally, you include developer tooling, such as CI/CD pipelines or integrated development environments, and like basically anything you can think under what is included in building, deploying, and monitoring applications. Then, a supply chain attack is a cyber attack that targets elements in the software supply chain. So, if you pull in some dependency and then that dependency has a vulnerability, it may act as a backdoor to your app. And similarly, it's like not only you who is vulnerable for that, but so is everyone else who pulled that same package. The attacks against companies have recently shifted from more traditional attacks like phishing and ransomware to these software supply chain attacks. And that's purely because they have a really, really big blast radius. And especially in the era of AI, there's more dependencies than ever being pulled into packages and apps. So to highlight this, I've highlighted one recent example, the Shai-Hulud attack, which has gotten its name from the science fiction franchise Dune. It's a self-replicating computer worm, and it's been active since September of last year, and it's still active to this day. To the right, I've highlighted kind of the basic flow of the attack. So it is essentially a minified bundle.js that then runs asynchronously during npm install. It uses Node.js's process.env, which is how the runtime environment gets access to environment variables, to then see if there's any GitHub credentials or NPM credentials, but also credentials to the 3 big hyperscalers, so Google Cloud, AWS, and Azure. Then if it finds a GitHub authentication token, like a personal access token, it's going to create a new repository called Shai-Hulud under that user with the found credentials. And then if the NPM authentication was found, it would use npm modules update package. So it first pulls in 20 packages owned by the user, and then it force pushes malicious updates, and that's how it kind of self-replicates. This original version of the attack attacked, for example, the Tinycolor package that has 3.7 million weekly downloads, but it did not go on for like super long. But instead, there's evolved variants of the computer worm. So there's Shai-Hulud with 1 and also mini Shai-Hulud. Specifically, mini Shai-Hulud hit TanStack packages. It's a very popular library of open source tooling for web development. And the packages that were hit have a combined 220 million weekly downloads, so quite a lot. There was actually a mini Shai-Hulud attack just yesterday, conveniently. Okay, I mean, not good for those who got attacked, but I mean, the worm is still very much active. And the evolved variants also attack packages on the Python package index PyPy. But this is by far not the only recent attacks. Here's a couple others that I've highlighted from this year. So Vercel got hacked by an employee giving a third-party AI tool allow all permissions to their professional Google Workspace. And Axios was hijacked with getting access to a maintainer's account. And similarly, Trivi was hijacked with a stolen personal access token. Trivi is actually a tool for supply chain security or visibility, so it does make them a very delicious target in that way. And they got attacked twice, and it's very likely that the second attack was the cause of another attack on Light LLM just a bit later, because they had used Trivi in their CI/CD. But this is not really news to anyone, and luckily EU authorities already forecast this many years ago, which has now manifested in the so-called EU Cyber Resilience Act. Petteri, do you mind telling us a bit more about it?
Sure. So, Cyber Resilience Act, it's something that is coming. Regulators in the EU forecasted this increase in supply chain security incidents already a decade ago. And it was already around 2016 when the EU Commission began their work to establish one supply chain security regulation within the whole EU. And rather than letting every single member country to implement their own regulations individually, they decided to create one EU-wide regulation, which is actually much more handy than having 27 different regulations to comply with. When it comes to CRA, the emphasis is on the manufacturers to become aware of their software supply chain. And being aware means having visibility on the supply chain, what kind of components are being used. And visibility is generic requirement for being able to react when it comes to supply chain attacks. And this is how CRA aims to solve the supply chain security. Being aware of your own supply chain and notifying others about discovered vulnerabilities, that's the main premise. So, what are the requirements? What does CRA require? First of all, you need to know your supply chain, and you need to be aware about the changes and newly discovered vulnerabilities in the components that belong in your supply chain. You need to monitor vulnerabilities in the components of your software that your software consists of, and you need to be able to demonstrate that your product does not contain any actively exploited vulnerabilities before you are allowed to bring your product to the European market. And when a new vulnerability is discovered from your dependencies, you need to report that finding to ENISA. And if that is an actively exploited vulnerability, that makes your own product vulnerable as well. So you have 24 hours to initially to file an initial warning report that there's something happening, something is going on, after which you have 48 hours to explain how you are going to patch it, what is your mitigation strategy, and then after you have patched the vulnerability, you have to finally submit a final report. How did you remediate from the supply chain attack? Then the next very natural question that comes to mind is that who is actually in the scope of the regulation? And basically, if you are doing any business around product that runs software, or your product contains digital elements in it, that's basically software, and you are selling that product in EU market, you are most likely in the scope of the regulation. So no matter whether you are a manufacturer, importer, or distributor, you are responsible of making sure that the manufacturer has followed the CRA requirements. If the product is contains digital elements, which means that there's something programmable in it, or if you have software that performs remote data processing, meaning that if you have an API backend and part of the calculations are done in the cloud, your product is within the scope of CRA. There are also a couple exceptions to this, and especially if your product is pure software as a service, you don't have any client apps, then your product is not directly within the scope of CRA. But if you have any customers using your product to build their products, they are still within the scope of CRA, and most likely they would like to outsource some of the vulnerability monitoring for the company who is actually producing the SaaS service. So even though they are not directly in the scope of CRA, there's it's quite likely that they should also be aware of their own supply chain. Also, if you are manufacturing products to a specific segment, let's say, for example, if you are building products for aviation, if you are building products for marine, if you are building products for financial sector, there's then specific regulation that you need to follow. And in that case, if you have a specific regulation to follow, then you don't have to follow the CRA. You follow the specific regulation, which typically contains similar measures regarding the software supply chain security. And the attacks actually magically don't go away, even if you are not within the scope of the CRA. It's a good idea to know what's actually in your software supply chain so that you can react to those attacks that Erika mentioned. Next up, Erika.
So the CRA implementation timeline is already in full swing. The original proposal was made almost 3 years ago, and it's become legally binding in December, about 1.5 years ago. Next month, you'll have to start. Next month, the national auditors are being chosen. So, and then after the summer, in September, you'll have to start reporting the vulnerabilities that you find. Then finally, in December of next year, you actually have to act on those vulnerabilities. So no more bringing of products that are vulnerable, and also you can't just let a product live on its own if there is a vulnerability. Let's take a glimpse into an example of a software supply chain. Here, we've sketched out a supply chain of a smart TV that probably many of you have at home. And just to highlight, this is probably like maybe 1/20th of the entire cake, but just to illustrate. On the left-hand side in purple, I've marked a bunch of vendors. These are definitely under the CRA. You probably recognize a lot of the name, like streaming services and streaming apps, app providers, and so on. And then on the right-hand side, we have open source components. So the CRA includes a concept called open source stewards. So you can't just make your app open source and then forget about the supply chain. Free and open source products are not included under the CRA, but yeah, making it open source is not a cheat-all way to just avoid the regulation. So here, it's, for example, if you take log4j, and there's a vulnerability found in log4j, then everyone kind of on the left of it who might use either log4j directly or then a component that uses log4j will have to make their own report to ENISA. But this raises a question. This is all very complicated. How can I keep my software supply chain secure?
Actually, when it comes to anything related to software supply chain security, we should begin by creating an SBOM. So here are two examples of the beginning of SBOM documents. There are multiple different SBOM formats. I have chosen SPDX here as well as CycloneDX, as those are the two most commonly used ones. There are some differences between them. SPDX is developed under the Linux Foundation, and it had from the beginning very strong focus on the licensing side, while CycloneDX is developed together with OWASP Foundation, and from the beginning they have had very strong focus on the security perspective. And at the beginning of the SBOM document, there's some metadata that allows you to link the SBOM document to your actual software artifact that it describes, as well as if you have a software artifact, you can then easily link it and refer it to an SBOM. Then the core part of SBOM document is the list of dependencies. The way the dependencies are described slightly varies between the different SBOM formats, but the idea is pretty much the same, so that you list the package version, the package name, and where it came from. And here we can see the colorful string value there. In SPDX, it's the reference locator, and then on the CycloneDX side, it's either bomref or PURL. And that's actually very important key point when it comes to SBOMs, because that's the value that is machine readable and can be connected to actual upstream components. And why this kind of format is important? It is because we have multiple different language ecosystems. And for example, PyPy packages are referenced differently than NPM packages. And this package URL spec, PURL, becomes very, very handy tool so that we can map every single package or upstream component under the same identification system. So here we can see where did the package came from, which packet it is, which version, and even include some qualifiers like which kind of build environment was used, which architecture was used, and even subpath, which files from the specific package were consumed. Then next up, okay, now we have the list of components, the dependencies that are part of our supply chain. But the next thing towards CRA compliance is to identify which vulnerabilities does the product, the specific build version, contain. And both formats have their own ways how this information could be included. In SPDX, you can create external refs and add a security reference in it. Or in Cyclone DX, there is a dedicated vulnerabilities section where you can list all the vulnerabilities. And that's the different approaches here are chosen because of the fact that once you have built your software, the list of dependencies is static. It doesn't change over time, while the vulnerabilities that exist is an updating list, because new vulnerabilities are discovered after the build. And these different approaches, in the Cyclone DX, they have chosen to have a dedicated vulnerabilities list, while SPDX developers decided that let's create a completely separate document called OpenVex to handle the vulnerability data in it. And this way the vulnerability information can live its own life, and it can be updated regardless of the SBOM. So the SBOM can be kept static the whole lifetime.
Wow, that's SBOMbastic. But yeah, so but once you've generated an SBOM, you of course have the question of what do you do with it? So software artifacts can have thousands of dependencies, hundreds if not thousands, and supply chain attacks are increasingly frequent, just like we learned. So it really is a core attack surface in modern systems. And basically how you solve it is to gain visibility over your system, which is exactly what a high quality SBOM gives. Ideally, you would say generate an SBOM per deployment and then link it to per deployment, and then when a vulnerability is disclosed, you know exactly what is affected. So then you don't really have like a need to rescan the container images, because the SBOM stays constant and you can just match that against vulnerability databases. And of course, it's much more convenient to detect the potential attacks before they happen than to see, okay, now there's like suspicious behavior in my system. Is there some problem? It's like, yeah, SBOMs give you like an edge in this aspect as well. So let's show our demo. We've made a very simple application with a Go app backend. It pulls the, you can see it here, JOT v4 library, which is basically a JOT token viewer. And then we can see the app live here. So there's just some JOT, and then if you preview it, you see the subject and the issuer for that JOT. So if you now stop this and make an SBOM, you see here I'm using Trivi, and I'm scanning for vulnerabilities. The format we use out of the two is Cyclone DX. I chose this format because it has the integrated vulnerabilities, so it's easier to just see everything in one document, and then we output it to an JSON. Here, this is the summary by Trivi itself, and you can see that this old version of the JOT library has two vulnerabilities, one high and one low, and we should be able to fix it by just upgrading the version. But before doing that, I'm just going to show the SBOM itself. Here you see it. Looks very familiar based on what we just saw. And then if we just go down, we see here vulnerabilities. So this is first the low vulnerability, that was not so important, and description, and then we have the high vulnerability. Yeah, it's the documents can be quite verbose, even this is like for one. So we can just patch this, where we just upgrade the version to 4.5.2 as indicated by the summary, and then we run go mod tidy, and we can generate a new SBOM. And suddenly this time there's no vulnerabilities anymore in the system. So what have we learned? But this is not all, unfortunately, because here we had like a very simple app with one dependency, but if your SBOM is not of good quality, it's really not that useful. There's, for example, post-install hooks that a lot of static analysis tools just ignore, in which case you're not going to have a complete SBOM, and you can't really use it to match vulnerabilities because there's like hidden dependencies. Similarly, if you include every single Linux kernel CVE, your SBOM is going to become really, really long. We already saw how long the existing for like one dependency, how long that is. So then you really need to have, first of all, make sure that you actually include everything, and then to have some way of actually parsing that information to make it useful. It's also important to, if you do continuous deployment, to always generate a new SBOM so that it changes when components in your app change as well. The CRA also doesn't ask for an SBOM, it asks for vulnerabilities. So then you also need to know, okay, now there's this vulnerability, but does it affect customer data, for example? Like, or is there some hidden vulnerability or something? So even for this reporting, like it's not only a thing about security, but also for compliance, that you really need to know what goes into your software. But compliance and supply chain security is very difficult, but this is actually exactly the type of problem we solve at Kraki. So if you want to hear more, you can drop by at our booth. So Petteri, what did we learn?
So, due to increasing rate of supply chain attacks, supply chain security is becoming more and more important. The increasing rate of supply chain attacks has also increased the pressure from the regulatory side to introduce new legislation, and we are now seeing that in the form of Cyber Resilience Act. And to be able to strengthen software supply chain security, we need visibility. And when it comes to visibility in software supply chain, SBOMs are the keys towards it. So yeah, thank you for listening our presentation. And yeah.